GTA Math, what's up? So today we're going to be doing a little bit more of a complicated problem because there's multiple applications to it. But this is an example of a product rule and a chain rule, and we're going to find the derivative of it. So the first thing I'm going to do is identify, yeesh, I'm going to identify my u and v terms. So I know this is an x squared, this is one term, and then this e to the negative 3x is its own term. So I'm going to call this u. I'm going to call this v. Whenever we do a product rule, we have to identify what the u is, which we said was x squared, and we have to take the derivative of that, and I like to call it u prime. And if you do the power rule of x squared, we end up with 2x. Next thing, we're going to do the same thing but for the v term. So we know that v equals e to the negative 3x. So we're not going to be taking the power rule specifically. We're going to have to chain rule this. That's a nasty looking e, and it's bothering me. That's even worse. So when we take the chain rule for a problem, not chain rule, but we take the derivative of something that's e to the x and there's a coefficient in front, really what we're doing is saying, okay, there's e to the negative 3x. We're going to take the derivative of this, and then we're going to bring it to the front. And then we're going to leave all of this the same. So I'm going to walk you through that again, that thought process. We're going to take the derivative. Oh, I don't want to do that. We're going to take the derivative of negative 3x, which is this. We're going to bring that here in front of this function, and we're going to leave all of this the same. So the derivative of negative 3x is just negative 3. So we're going to end up with negative 3, and then we're going to keep everything else the same. So we're going to keep this e to the negative 3x. And then when we multiply it, it's really just negative 3 e to the negative 3x. So this is going to be our v1, which is a pretty big step in a problem. Because if you get that part wrong, your derivative is going to look crazy. I've been there before. Check my exam. So now we're going to use the product rule and put all this information together. So when you're using the product rule, I don't know what your teacher showed you in class, but I use the UV method, as you can see. So I'm going to take this u, I'm going to multiply it by v prime. I'm going to add that to v, then multiply it by u prime. So now we're just plugging the information that we have above into these different variables. So when we get here, we're going to say, okay, y prime equals u, which is x squared. And I'm going to use the derivatives in different colors just to make things look a little cleaner. V prime, which is negative 3e to the negative 3x. And then we're adding, so I'm going to make this red. And then we're going to use our v term, which is just e to the negative 3x. And then our last derivative is u prime, which we already said was 2x. So now we're just distributing and simplifying. So this part is a lot easier compared to the steps we did prior. If you make it to this part, you've already completed 80% of the problem. Well, 75. Because I would say identifying your u and v part, that's getting that right, is 25%. Plugging everything in, that's another 25%. Simplifying and reducing is the last half of the problem. So once you get here, you're at the home stretch. You've done all the calculus. So x squared times negative 3 e to the negative 3x. I'm going to write it as negative 3x squared e to the negative 3x. However you choose to write it is completely up to you. I just like to put my x's before other variables because that's just kind of how I'm trained at this point in life. And 2x times this other e to the x function. So we got 2x. And then we're just going to bring the e to the negative 3x here. And if you get here, this should be a good enough answer. But your teacher may want you to simplify and factor some stuff out. So if that is the case, I will walk you through the next step. So I would say y prime equals, this one is factored out. So I noticed there's an x, there's an e to the negative 3x in both of these, and the constants are different, and we can't factor anything out of this. So that's going to have to stay. So I'm going to rewrite it. I'm going to write this as 2x e to the negative 3x. It doesn't really matter, but I want to have the positive number in the front. And then I'm going to factor it out from here. So I'm going to take x, e to the x, e to the negative 3x, leave that in the front. And since we can't do anything with this 2 and this negative 3, we're going to have to put it in parentheses. So it's going to be 2, yeah, and this actually, well, not the x squared part, but just the x, minus 3x. And this is actually our final answer in factored form. Both of these answers are the same thing, though. Please don't feel they're different, because they're not, I promise you. Ooh, that's bad. But yeah, I hope you found this helpful. Some of these derivatives get tricky. I'm not even an expert at them. I'm doing some of the homework problems I didn't finish throughout the semester. Just trying to make sure that I brush up on my skills going into Calc 2. So for the most part, if you get stuck on any of these problems, I'm going to actually make videos and kind of walk through how the derivative rule works for certain problems. Like chain rule can be tough, especially with e to the x and when there's negatives and stuff. Some of the natural law derivatives get funny acting too, but for the most part, if you made it through this is a pretty tough problem, especially going into a derivatives exam. Like this is an exam question, I feel, because it's chain rule component, there is a product rule, and there's some factoring you would have to do. So this is a good exam question if you have a 60-minute lecture. So if you can do something like this, you're in pretty good shape, because derivatives are tricky, and this is one of the ones that is kind of like, you know, higher tier. But for the most part, if you enjoyed this, please feel free to tune in. I'm going to post more content. Thanks for joining GTA. learn love. Let's all grow together. Keep working hard, everybody. Take care.